Hello, welcome to today's class. Today we are going to discuss about onto functions, and we shall be taking a few questions, different types of questions, and we'll check how to show or how to find whether they are onto or not. So we are going to discuss about a quadratic function, a cubic function probably, and trigonometric function and exponential function. Okay, so we'll discuss one by one. Before that, let us start with what is the onto function. Any function f from a to b, domain to codomain, is said to be onto if all the members in the codomain are images. So here this 1, 2 and 3 are mapped to x and y, means the range of this function is the set containing x and y, which is not equal to codomain. So had it been equal to the codomain, we would have said this function to be onto. So definitely this is an example of not onto function. In fact, this is a into function. Not onto. Now let us go for the second example. Here I am taking the second function f2. It is running from a to b. 1, 2 and 3. 1 and 2 is mapping to p and 3 is mapping to q. So if I go for the range of this function, range of the function means the set containing all the images. So range of the function is this, and which is exactly equal to the codomain. So we can say this function to be onto. Similarly, this function f3 running from a to b. So all the members are going for x, y, z, w. So range of this function is set containing the images, which is exactly equal to the codomain. So ultimately, this also is the example of a onto function. So what I'm trying to tell you is, whenever we have to go to check for onto, and whenever we are talking about onto, we'll always look for the range of the function. We'll try to find out the range and we'll check whether it is equal to the given codomain or not. If it is exactly equal to the codomain, we'll declare it to be onto. Otherwise, we'll say that that function is not onto. As simple as that. So I'm just writing out the definition. A function f from a to b is said to be onto if the codomain b is equal to the range of f. As simple as that. Okay, so let us discuss a few examples. Okay, we'll go one by one. So basically what we are going to do is, we'll try to find out the range and we'll check whether it is equal to the given codomain or not. Now this function is running from r plus. R plus is set of non-negative real numbers, means this is nothing but 0 to infinity. Okay, it is running from 0 to infinity to k to infinity, given by fx equal to 9x square plus 6x minus 3. And this one is nothing, this is the definition of the function. This is how the functional x and fx are related, and it is given to be onto. It is given that this function is onto, and we have to find out the value of k. Okay, so let us see how to do this. Quadratic function, we have already learned in class 11 how to find out the range. Okay, we'll go for it. This one is 3x plus 1 whole square minus 4. We'll express x in terms of y. Y plus 4 will be equal to 3x plus 1 whole square. So ultimately I will get 3x plus 1 as plus minus square root of y plus 4. So x will be equal to minus 1 plus minus root over y plus 4 upon 3. Okay, now we have to check from which values of x this y are possible. because we know the values of x where it lies. They are real and positive. In fact, they are non-negative. Okay, so for x belonging to 0 to infinity, we must get this one to be positive, means this entire portion is positive, minus 1 plus minus root over y plus 4 by 3 is greater than or equal to 0. So from here I will be getting y plus 4 square root will be greater than equal to 1. So y plus 4 greater than equal to 1. Y will be greater than equal to minus 3. So range of the function is minus 3 to infinity. Since the function is already given to be onto, so I must get, therefore the value of k should be equal to minus 3. So if k equal to minus 3, then this function will become onto. That is what the answer of the question. Okay, I hope you have understood very easily. Okay, so let us go for the next question. F running from R to minus 10 comma 0 given by fx equal to sine square x minus 5 sin x minus 6. To check whether it is onto or not, whether it is f is given by this is onto. Check. Check if the function running from real number to minus 10 comma 0 close interval given by fx equal to sine square x minus 5 sin x minus 6 is onto or not. Okay, so if we'll observe, we'll find that this one is nothing but a quadratic in sin x, and sin x we know a bounded function. Okay, bounded function means we know the range of sin x, right? It is lying between minus 1 to 1 close interval. So we can use that boundedness of sin x here. We'll try to use that. So let us convert this one into quadratic in sin x, when we'll be getting sin x minus 5 by 2 whole square minus, and calculation will be minus 49 by 4. Yes. Okay. Now this one you see. Now function is reduced to the variable only to sin x, and this function is bounded. This we know the maximum and minimum value of this. Okay, so just we'll put down the maximum and minimum value of sin x. That is, we know that maximum value is at 1, minimum value at minus 1, but we have to check which, that is the maximum and minimum value of sin x, but we have to check what are the maximum and minimum value of fx. Okay, so f minimum. So we've seen that f will be minimum when sin x will be equal to 1. So here I will be getting 1 minus 5 by 2, that is 3 by minus 3 by 2 का whole square, मतलब minus plus 9 by 4 minus 49 by 4, that is I'm going to get minus 10 at x equal to 1. And we'll try to find out the maximum value, f maximum. f will be maximum when sin x is -1. So -1 minus 5 by 2 whole square minus 49 by 4. So here I'll be getting 7 by 2 whole square, that is 49 by 4 minus 49 by 4. So it is giving me 0. Therefore range of the function, it is going from -10 to 0 closed, which is exactly equal to the given codomain. So therefore f is onto. They have asked us to check whether f is onto, so we have checked the range. We have found out the range, and it is exactly coming out to be equal to codomain. So we'll declare that the function is onto. Okay, so let us go for another question, another kind of question. Check whether it is onto. Okay, so again we'll take this one to be equal to y. Try to find out the range. If it is exactly equal to the given codomain sum, we'll declare it to be onto. So y plus yx squared 1 minus x squared. So x squared will be taken common here. So we'll be getting y plus 1 is equal to 1 minus y. So x squared will be equal to 1 minus y by 1 plus y, and x will be equal to plus minus of square root of 1 minus y by 1 plus y. Now we have to check for what values of y this x will become in the domain. So for x to be a real number, this value has to be positive, which is lying under the square root. So where it is positive, that can be very easily found out from the wavy curve method. So the critical points are -1 and 1. Here it is positive, there it is negative. So it will start with a negative sign, negative, positive, negative. So for x to be belonging to real numbers, we must have y must belonging to -1 to 1. Now the question is whether y can take -1. No, y -1 will make denominator 0, which is not possible. So -1 excluded and 1 can be included. That is range of the function, that is the value of y, is open interval -1, closed interval 1, which is equal to codomain. Therefore f is onto. So basically all the functions, whenever onto is coming, we are trying to get the range of the function. Okay, check whether it is onto. Now for doing this question, I'll take the help of the graph. Okay, and I'll bring little bit of concept of calculus out here. So to draw the graph, these are the things I need to check whether when x equal to 0, what is the value of y? Y equal to x equal to 0, y equal to 0. I'll take this one, fx equal to y. And when y equal to 0, this x equal to 0 implies y equal to 0, and y equal to 0 implies x equal to 0 and plus minus 1, right? X into x square minus 1 equal to 0. So this one is giving me the curve passes through origin. This is giving me y equal to 0 means x-axis, where the curve cuts the x-axis. This one is giving me that. Those are the points. Okay, -1, +1 and 0. 0 already we have got in the first. Third, we'll try to check whether the graph is going to take some turn, and if it is going to take turn, which are those points at which the curve will take some turn, if at all. Okay, so for that we'll find out after 6. which is 3x square minus 1. So f dash x equal to 0 implies x will be equal to plus minus of 1 by root 3. So the curve will take turn twice, where once at minus 1 by root 3 and the other time at plus 1 by root 3. Okay, again f dash x 3x square minus 1 is positive when x is greater than less than equal to minus 1 by root 3 or x is greater than equal to 1 by root 3, and negative if x is lying between minus 1 by root 3 to 1 by root 3. So showing us that in this interval the function is increasing, and in this interval the function is decreasing. Now we'll try to find out the maximum and minimum value, okay, of fx. So for that we need f double dash x. F double dash x will be 6x, which will be greater than 0 when x is, the critical points are 1 by root 3 and minus 1 by root 3, x equal to 1 by root 3. This minimum means positive, f double dash x is positive, so x equal to 1 by root 3 is a point of minimum, and is equal to is less than 0 when x equal to minus 1 by root 3. So this is a point of local maximum. Now we'll check at which point, at what point the function changes its concativity. Okay, so for that we have to equate f double dash x to 0. Okay, so 6x equal to 0 means x equal to 0. So at x equal to 0, the function will, the graph of the function will change its concativity. So we'll club all this to draw the graph of this function. Okay, and from there we'll try to find out what is the range of it. Okay, obviously I know this, the range is minus infinity to infinity. This is all cubic function, they have the range of real numbers. Okay, but I wish to discuss this question not because that it is a cubic function and we must know that a cubic function range is always real number, but we need to know how to make the conclusion. Okay, why is it so? Okay, so let us go for it. So we'll club all this to draw the graph. So graph will be running out of space. Definitely it will pass through x equal to 0, y equal to 0, and it is passing y equal to 0 at x equal to plus minus 1. So the graph will cut the x-axis at these points. So let me mark those. The graph of the function will cut the x-axis at these points 0, minus 1 and 1. So 0, minus 1 and 1. Okay, now it has a maxima at minus x equal to minus 1 by root 3. So minus 1 by root 3 will be somewhere here. So here it will have a maxima, and at 1 by root 3 it will have a minimum. One more thing we can notice here, this function is an odd function. If we replace f of minus x, we will get minus of fx. So this also telling me something. This function is, the graph of this function will be symmetric about the origin. Okay. So the graph, this increasing in when it is x is lesser than equal to minus 1 by root 3 and x is greater than equal to 1 by root 3. So the graph will be increasing beyond these points. These points are minus 1 by root 3 and 1 by root 3. Those points beyond the graph will increase, and in this interval the graph will decrease. What else? The graph will change its concativity at here, at x equal to 0. Graph changes its concativity. Okay, so we'll combine all these facts to get the graph. Like this. Okay, at minus 1 by root 3 it has a local maxima, at 1 by root 3 it will have a local minima. Okay, minus 1 by root 3, say beyond this in the left hand side it is increasing, and 1 by root 3 beyond this point also it is increasing. Between minus 1 by root 3 and 1 by root 3 it is decreasing. Okay, and the graph is changing its concativity at x equal to 0. So we have drawn the graph, and quite clearly we can see the domains are obvious, and the range from it is going to positive infinity and it is also going towards negative infinity. So the range of the function is R, implies f is onto. Okay, so it is given to be onto, and we have to get the value of k. Okay, so here in this question also I am going to take the help of graph. Okay, so we'll again find out at x equal to 0, y will be equal to 0 if I consider this one to be y, fx equal to y. And when y equal to 0, x equal to 0. So here only one thing will get. Second, we'll check whether this function is going to take any turn, the graph of the function obviously. So for that we need f dash x. F dash x will be equal to x into power x plus into power x. So into power x, x plus 1. So this one will be equal to, implies this one cannot be equal to 0. So this one has to be equal to 0. F dash x equal to 0 if we will equate to get the turn where the graph is taking a turn. Graph take a turn. Graph takes a turn at x equal to minus 1. Next we'll try to figure out the maximum and minimum value if I can get f double dash x. F double dash x I'll be getting in order x into x plus 2. Okay, and this one will be equal to 0. Equal to 0 implies graph changes concativity at x equal to minus 2. Right? Can I find out the maximum and minimum value? F double dash minus 1. F double dash minus 1 is e to the power. F double dash minus 1 is equal to e to the power minus 1 into 1. That is positive for all x. Positive implies f has a minima at x equal to minus 1. and f minimum is, we'll put the value of x equal to minus 1 here to get minus e to the power minus 1, that is minus 1 by e. This is the minimum value. And since the graph is not taking any turn anywhere else, so to get the maximum value we have to evaluate the limit of the function. We have to check how this function is going to behave in and around infinity in both the ways. Positive infinity, infinity into e to the power infinity, so it is going towards infinity only. So we'll try to draw the graph now. Positive infinity, this graph will going towards infinity. Now negative infinity we have to check, and we have to find out, and we have to evaluate the limit probably to check how this function is behaving in and around negative infinity. So let us go for it. Limit x tends to minus infinity fx is, that is x into the power x. So minus infinity into e to the power, this one is which form? 0 into infinity form, undeterminate form, indeterminate form. So limit x tends to minus infinity. How we'll do this? We'll try to change into infinity by infinity or 0 by 0 form so that we can use L'Hopital's rule. So x e to the power minus x I'll do. So it will become infinity minus infinity by infinity. So minus infinity by infinity form. So we can use now L'Hopital's rule. And if I use that, limit x tends to minus infinity, I'll be getting 1 minus e to the power minus x. So if I put a limit, this one will become infinity, 1 by infinity is 0, so it is tending to negative of 0. Negative 0. Because of this negative sign, right? So negative 0. So when x is tending to minus infinity, the function will tend to negative of 0. So negative of 0 is somewhere here, this being 0. So when x is tending to positive infinity, function will tend to infinity only. But when the function is tending to negative infinity, the function x is tending to negative infinity, the function will tend to negative 0. So very close to x-axis on the left hand side of y-axis, negative 0. Okay, so now we'll try to draw the graph. The function is passing through, the graph is passing through origin. Critical point at x equal to minus 1. So here we'll have a turn. Minimum value at minus 1 by e, and it is obtained at f equal to minus 1. The minus 1, so here it will be the minimum value 0 comma minus 1 by e, and the concativity of the graph changes at x equal to minus 2, and the graph is tending to negative 0 when x is tending to negative infinity. So the graph will be somewhat like this. It will change the concativity at minus 2. It will go like this. This is the point of minima, so it has to increase after that. Okay, it will pass through 0 and it is going to increase. Okay, so tentative graph of the function will be something this. Okay then, now we can answer any question really. The question was, we have to find out the value of k if this function is onto. So range of this function, range of f, clearly it is minus values of y, right? So minus 1 by e to infinity. So by comparing with that, we'll get k equal to, therefore k equal to minus 1 by e. This is the answer. We can we can answer any kind of question actually after drawing the graph. So by giving this question, by taking this question, I am more interested in drawing the graph than to do the question of 1 2 actually. That was my intention. Okay, anyway, thank you for joining me for this class. We'll discuss about bisective function in my coming up class. Thanks for watching.